This lesson returns to arcpy functionality to discuss the mapping module capabilities. arcpy can automate map publication and manage existing documents. The mapping module has Python classes that mimic the organization of ArcMap. Keep in mind our recent discussion of user-defined classes. The terms property and attribute will reappear as we go over these mapping classes. In this lecture, you will see how to manipulate, add, remove, and move map layers, how to modify map surrounds, such as the title and north arrow, and finally, how to modify the symbology of map layers. Taking a look at the arcpy cheat sheet once more, there is a purple box on the right side of the sheet for the mapping module. As I mentioned, the mapping module allows you to modify existing map documents. It can also get the extent, take a screenshot of what's on the map, add layers to the map, rearrange layers, zoom, list information about the map, such as the data frames and layers, and there's also a way to automate checking for broken links in maps. To do these things, the mapping module uses several classes. So again, that should tie into what you already know about classes. The mapping module has a set of classes and a set of functions. Looking at the online help for the mapping module, you'll see a folder for classes expanded in the left screenshot and a folder for functions expanded in the right screenshot. The classes include a MapDocument, a DataFrame class, a layer class, and many others. The functions are grouped into two categories: functions for exporting and printing the map, and then the other category is for managing documents and layers. Notice the alphabetical help lists of classes and functions in the left image. These are useful to print so that you can reference them while working with the mapping module. To use any of the functions we saw in the right screenshot on the previous slide, we use double dot notation. Mapping is a module that resides under the arcpy package. Similar to env, we say arcpy.mapping.function name. For example, arcpy.mapping.export to PNG. Export to PNG is a function which takes a screenshot of the map that you specify and saves it as a PNG file. Here's a very simple example of a script that uses the mapping module. We import arcpy, specify the full path file name of a map, an existing map that looks like what we see up in the right corner, and we have to create a MapDocument object in order to call the export to PNG function. So that's what line 3 does. And then on line 4, we pass in that MXD object that we've created. And the second argument is the location where we want the PNG to be written in the file name. In line 5, we delete that MapDocument object so that the map is not locked. Let's look more closely at the MapDocument object from line 3. For most of the mapping module scripts, you have to create a MapDocument object. It's a required input argument for many of the functions, just like we saw it was for export to PNG. Looking at the syntax for creating a MapDocument object, it's arcpy.mapping.mapDocument because mapping is a module and MapDocument is a class inside of the mapping module. So here we are instantiating an instance of a map object. The map object init function needs you to pass in a map name. It's got to be the full file path name because it doesn't understand it doesn't work with the arcpy.env.workspace. So otherwise it won't know where your map is. You have to tell it the full path. So we invoke that constructor and it returns a MapDocument object. Now that MapDocument object has a number of properties. The in-class exercise linked to the course page explore map documents, MapDocument objects is designed to just familiarize you with some of those properties. Now notice that this exercise, the instructions tell you to start by copying an existing map from your sample scripts into the Scratch directory because you're going to make changes to the map. Open the map in ArcMap. Open the ArcMap Python scripting window. This exercise is to be done inside of that scripting window instead of inside of your IDE. And the reason for that is this is a useful time to use that Python scripting window because you can see changes you make with the MapDocument object on the map directly when you refresh with the code. Pause the video now and try this to see what it looks like. MXD is a MapDocument object. MXD.RelativePaths is Boolean, and it means, does the map use a relative path to the data layers? This is an important setting. If you have the map and your data in the same directory, and you don't have this turned to true, and you change the name of the directory, the map won't be able to find the data layers. So you'll see red exclamation points in the table of contents. How can you change mxd.filePath from a Python script? Well, you use an assignment statement, or you can try, but this is actually a trick question. You can't change the file path from a Python script because the Python script doesn't have the power to move the document. How do you get or change the author of a map from a Python script? Code that looks like this. You can use an assignment statement with that property, and it has changed. The difference between these two is file path is read only and author is read and write. You have both accesses. How can you force the map to refresh to show changes you've made in the current session? You can use that refresh active view method that's there under arcpy. When you moved over to the Python Win IDE, you found that some of the calls to the MapDocument class constructor did not work. The first one was the one that contained the string current. Current means you're working in the current map document, and it doesn't know what that means when you're outside in Python Win. The next one, you tried setting the workspace to the directory where the map was residing, and then setting the map name to the base name of the map, states.mxd. Then when you try to create a map document object, this throws an assertion error. It says invalid MXD name because it can't find the map document. Because the arcpy.env.workspace is really designed for the running of tools. It does not impact the mapping module. The mapping module was added on later, and they decided not to have it heed the workspace setting. The third one worked. This was the full path file name of the map. Then we made a change to the map document and tried to save it, and that failed too. We'll talk about that more on the next slide. What does os.startFile do? It takes an argument, whatever argument that is. It uses the default program for launching that type of file. So for example, a map document object, when that is passed into os.startFile, it automatically opens ArcMap with that map open. Where can you find a list of all the map document properties and methods? Well, in the online help. And you can type something like arcpy map document class into your search engine, and that should get you to the web page. On that web page, you'll find a table of properties, and the properties will say whether or not they can be modified by the fact that they say read only or read write in front of them. The other alternative is to just try modifying them and see what happens. When we did the save command, I had specifically said to leave ArcMap open with that same document and then try these commands in the interactive window in Python Win. This is because I wanted to demonstrate that if you have the map document open in ArcMap and you try to save changes to that map document in your Python script, in your standalone Python script, you are going to get into trouble because the map document is locked by ArcMap. So that's why it throws an error and starts talking to you about the amount of storage space, but that's not the real problem. It's a standard I/O error that is occurring because the document is in use with another application that has locked it. If you want to make changes to that document, you can save a copy. You can call the save a copy command with a different file name, and that will work okay. Then you can make additional changes to that file. So as long as that map file is not being used currently by ArcMap, then you can call that save function and that will work fine. You can specify the map document as current when you're inside of the Python window inside of ArcMap, or when you are running a script tool inside of ArcMap that points to a script with the word current in it. I'll show you an example. The script looks like this. Now if I try to run this script inside of the Python window, it will break because it doesn't know what current means. But I'm pointing to this same script with my script tool in ArcMap that's pointing to test current script. Doesn't take any parameters. Just run that. Unfortunately, it popped up and covered up the title that was changing at the same time as it was being run. But that's because I had a command in there to change the title. And as you can see, it changed the title successfully. Now, can I save that map document when I'm running my script tool inside of the ArcMap environment? Though this script calls refresh active view on line 5, it didn't need to have that in there to see the change in the title. I have an after statement in here to see if it fails. We'll run it again. And it saved the change because it got to that after statement. So that works okay too. If we try to run that same script in Python Win, we see that it fails. So if you're going to develop a script for your project where you want it to use current, you're going to have to temporarily, while you're developing the code outside of ArcMap, so that you can debug it, you're going to have to use that full path file name. And in the homework assignments, we have you use the full path file name because we don't want to have to launch ArcMap to run the code for each student. Since you're familiar with ArcMap, you know that there's a hierarchy in how map documents are created. There's a map document which has data frames, and you can have multiple data frames depending on your application, and you can have layers within each of those data frames. Our classes in the mapping module are designed in the same way. The listDataFrames method returns a list of data frame objects. You call this by creating a map document object and then passing that map document object into the listDataFrames method. It returns a Python list of data frame objects. So if you know there is one data frame, at least, you can index into that first data frame. By default, when you create a map document, it contains a data frame, so that's a pretty safe assumption. Here we're printing out that DataFrame object. So you can't just use it directly, you have to say .name. It has a name property. And we're going to set up a second DataFrame object by indexing into that list again. When we do that, we have another DataFrame object. These have an extent method, and the extent method returns a bounding box for the data frame. The data frame extent has ymin, ymax, xmin, xmax properties. So this is an extent object which has its own properties. You can zoom to a layer by selecting a layer by attribute and then zooming to the selected features in the map. Zooming to selected features is a data frame object method, so you have to know what data frame you're within before you can call that method on the data frame object. You can also list layers. You can do this in several different ways because it has some optional parameters. You can specify the data frame within which you want to list the layers, and that's what this example does. The listLayers method has one required argument, the MapDocument object, and can take up to 2 optional parameters: the wildcard to specify some kind of naming requirement for the layers that you collect, and the data frame so that you can specify which data frame within which to list the layers. First, you're going to need that MapDocument object regardless, so create that, and then we list the data frames. We get that first data frame, which is the northeast. This call to list layers passes in that MapDocument object. This is the wildcard, so the layer name can have any pattern in it. If you wanted to find layers that started with V, for example, you'd put V star in here. And then the third argument that's being passed in here is the data frame. So this means we're only going to list layers within that first data frame. If you leave that data frame parameter out, then it will list layers for the entire document. ListLayers method returns a list of layer objects, and we can loop through those, print the name of the layer with a name property. Try this out. Best way to learn these things is to try them in the in-class exercises. So pause your video now and follow the instructions under Explore Data Frame and Layer Objects. Try to answer the questions before you resume the video. Now for our answers. How can you list all the layers? By calling the listLayers method with only the MapDocument object argument. Don't specify a data frame and you'll get all of the layers from all of the frames. How can you use Python to zoom? We've seen one method, which was to call the Select Layer by Attribute tool, and then use the data frame method zoom to selected features. Or we saw a new method in this exercise, which was to get the extent of a layer and then set the extent of the data frame to that layer. How could you get the 5th layer in the 3rd data frame of a map that had such a configuration? Well, because you know how you index into the list of data frames. To get the 3rd one, it's 0 base, so we'd say DFS2, and then we can list all of the layers in that data frame. And to get the 5th one, we would index 4. Where can you find a complete list of layers and methods? Certainly the online help will have all of the properties and methods for layer objects. arcpy mapping module can move, remove, or add layers in an existing map document. To do this in your code, you first need to instantiate a MapDocument object and a DataFrame object. The names of the manipulation methods are listed here. As you can see, they allow you to add a layer either to the top or the bottom, insert a layer and be more specific about where you're inserting it, move a layer and specify where you're moving it to, remove a layer, and update a layer. And this you can use to set the symbology of a layer. Here's a simple example in which we remove a layer. In fact, we're removing the first layer of the first frame. We set up the MapDocument object, get a list of data frames, and take our first data frame, and then we get a list of layers within that data frame. We set a variable to the first layer. We call it layer to remove because that's what we're going to do with it. And then on line 22, we call the remove layer method. arcpy.mapping.removeLayer specify the data frame from which to remove it and the layer to remove. The rest of the code is saving the map document and deleting the map document object. So the core there is calling that remove layers. We have to have a data frame to remove it from, and to get that data frame we have to get that map document object, and then we have to have a layer object to remove. You notice you're not passing in the name of the layer here. You have to pass in the layer object itself. So you have to use listLayers or some other methodology to get the layer object. Here's another sample script which adds a feature layer. Again, we create that map document object and get our data frame. Then we create a layer object. This is a little different from the other one because we don't have an existing layer object. We have to create it. We have to specify our data. In this case, our data file is ma.shp, which lives in this Chapter 24 data directory. Pass that in calling the layer class to create a layer object. We create that layer object and then we can add that layer to the map. We have to specify the data frame to which we want to add it, then pass in the layer object that we want to add. There's another optional argument that has to do with where you want to add it, but this is just adding it in the default way. Try this exercise to get some practice looping through data frames and layers. Add a raster dataset to the state.mxt document by hand so that you have an example of a raster layer in that map, and then add code to the code that's given to print the name of the data frames and feature layers, feature type layers in a map. In other words, not the raster layer. And they should come out looking like we have in this picture. 2 hints. You're going to need nested looping to loop through the data frames and the layers, and you're going to make use of a property called isFeatureLayer. Pause the video now and go over to the in-class page to try it. Your result should look something like this. The lines 1 through 10 were given, so the interesting part starts at line 11. You should be looping through the layers and referencing that isFeatureLayer property and then printing the result. By saying if isFeatureLayer, we're filtering out any non-feature layers of the map. Here's another interesting example that you might use if you were TA for GIS540. There you are getting a lot of map documents submitted, and sometimes they have broken links. You could quickly run a script like this and identify the maps with the broken links to notify students in efficient fashion that they've been turning in maps that are not referencing the data properly, or they've missed the submission of the data. The function involved here is called on line 10, arcpy.mapping list broken data sources. So this script basically gets a... Here's another example of using the mapping module. In this example, we're finding the broken links in the maps within a given directory. On line 6, the user passes in an argument, and 7, we list the files in that directory. On line 9, we get a list of MXD files that are within that directory. And on line 11, we loop through those MXD files, create an MXD object inside the loop, and then list the broken data sources for that MXD object. We print the name of the map and print the name of the broken data source, and then we delete that MapDocument object. You can imagine using an application like this if you're sharing a lot of map documents in your company and they're not using map packages, or if you are TAing for a GIS course where people are submitting maps with broken links. arcpy also lets you manage layout elements. By layout elements, we mean things like the title or the legend, those things that surround the map surrounds. Now, arcpy cannot create new elements. For projects where you want to modify layout elements, you should create a map document that you use and send with the project as a template that can be modified with your code. The template map elements can be hidden. They can be slid off the map so that you can't see them in the initial view, and then the code can move them to the positions that you specify. Now, getting a layout element to modify it requires you to know the name of the element. So when you add an element to the map, it gets a name. You might not have noticed that, but it's automatically defined. It's automatically assigned a name. And for some of the defaults, the default name is an empty string. So you have to, when you create your template, use meaningful names for each element in the map template. That way your code can point to them distinctly. The flow for managing layout elements usually looks like this. You get a map document object, you get layout elements of interest, and then you modify the layout element, save the map, and delete the map document object. arcpy also allows you to manage layout elements such as title, legend, north arrow, and so forth. arcpy cannot create new elements. So for projects where you want to modify layout elements, create a map as a template map and put in all of the elements that you want to have there, and then use the code to modify their values. The template map can have elements that are hidden outside of the initial viewing box, and then your code can move the elements to different positions. When you want to get a layout element to modify its properties within your code, you often need to know the element's name or some other aspect of it. When you add an element to a map document, it automatically gets a name. However, for some elements, the default name is an empty string, like for text elements. So create your template with meaningful names for each element in the map, and then you'll be able to refer to them easily in the code. Your layout workflow will look something like this. Get the map document object, get the layout element or elements of interest, modify the layout element properties, and save the map. Delete the map document object. Here's an example in the code here where we create the MapDocument object, and then we loop through we get a list of all of the elements in the map with the listLayoutElements method. We get a list of all of the elements that are text element type. So then we loop through those elements and we checked if the text in the box is 2009. If it is, we want to change it to 2010 to update it. Then we save and delete the map. So this is an example where we didn't have the name for the text box, but we knew the unique property, the text value. We knew that there weren't any other 2009s on the map, or if there are, that means we're going to be changing all of them to 2010. Let's look a little bit more closely at that listLayoutElements method. The listLayoutElements method takes three parameters. The first is required, the MapDocument object. The second is optional, and the third is optional. The second is the element type. These are the potential values for the element type. You pass them in as a string, and they have to be as shown with the capitals and the underscore. The wildcard is there in case you want to specify a particular substring for the name of the element. Now notice that element type is optional, but it cannot have a placeholder in there. You must use a legitimate element type if you want to use the wildcard after that. Here are some more examples. If you just want to list all of the elements in the map, you can say listLayoutElements and pass in the MapDocument object. To get only the picture elements in the map, you would specify that as the element type. To get the text elements whose name starts with HOR, you would call listLayoutElements in this way. Now take a moment and try to explain to your neighbor or your cat or to yourself what each of these pieces of code is doing. Pause the video for a moment and give it a try to see if you understood what we just went over. Now let's resume. The first part prints the name of the north arrow. We get this by listing all the layout elements, and we know that our name of our layout element that has the arrow in it has the word arrow in the name. We get that MapDocument object first, and then we pass that in and call the listLayoutElements with the MapSurroundElement type. Then we use a wildcard to find any element that has the word arrow in the name at any position. Next, we index into that list to get the first item that has that word that has qualified. We probably know that our north arrow is the only element in there that is named with an arrow in it. We print out the name and we find north arrow. Part 2 starts by printing the names of all of the elements in the map. We call this layout elements with just MXD, and then we loop through there and print out the names. Next, we get the element named title. We loop through the same list that we got before, and if title is in the name, we set the variable named title to that element. Another way to do this very same thing would be to pass in all three arguments and specify title with no wildcard in it. The last one moves the title to the center top of the first data frame. We get the MapDocument object, the first data frame, and then we modify the X and Y values of the title object. We do that by adding the data frame X position to half of the data frame X position. So we're starting in the left corner, we go halfway to the middle, and then we subtract half of the width of the title. And we do something similar here, except we're moving it all the way to the top. So we take the Y position of the data frame and add the height of the data frame. The 0 position is in the bottom left corner. And then we subtract the height of the element, so it's not going to be up off the top. You can also modify the symbology of a layer in a map with the arcpy module. Layer objects have a symbologyType property, which can have any one of these 5 values. We see layer 1 has a property type of other, layer 2 graduated colors. Depending on its symbol type, a layer can have a symbology class or not. The other type ones do not have a symbology property, so if you try to use it, you'll get a name error. And our layer 2 does have a symbology property. Now, Python can't change a layer's symbology type with an assignment statement like this, but you can use layer files to do this. And a layer file is a file that has a .lyr extension and stores a symbology for a data set. When you add an LYR file to a map, it uses the stored symbology type. Otherwise, the default symbology type is other for any data that is added to the map that is not an LYR file. So to change the symbology type of a layer in your map, which you may want to do because you may be generating layers and adding them to the map, you can use the update layer method. This takes 3 arguments: the data frame, the layer whose symbology you want to update, and a training layer that we can use that .lyr file, create a layer object out of that. So both of these are actually layer objects, and we pass the one that has the symbology type that we want in as the 3rd argument, and our layer to modify gets that symbology. The one that we passed in had a symbology of graduated colors. Now we can change the symbology properties of the layer that we just modified. We can change the value field for calculating the colors and the number of color classes. Here we're checking the value field. It's based, so the value field tells it which field, the name of the field that it's going to calculate the classes or the graduated colors on. And we're setting that to a different value here. So initially it was category, we set it to average family size, and then we check the number of classes in the graduated color. Initially it's 5, but we can set it to a different value. We've set it to the number 3. This lecture covered most of the functionality of the arcpy mapping module. We saw that there are MapDocument, DataFrame, and layer objects. We know that we can use the full path file name of a MapDocument when we're outside of the ArcMap environment, and when we're inside we can use current to create the MapDocument object. We saw how to check and modify MapDocument properties, list map objects such as data frames and layers, and we can save the MapDocument with the changes that we make, and we can remove, modify, and add layers. We can modify the layout elements, such as the position of the north arrow or the text in a text box. And finally, we can modify the symbology if we have a training layer that we can base the symbology on.